All right, so in this video, I'm going to go through some of our homework questions on the complex inheritance. So in the previous lecture, we talked about incomplete dominance versus codominance, and then we also talked a little bit about polygenic inheritance. And so these are traits or instances where true Mendelian genetics is not followed. Okay, so remember with Gregor-Mendel and his pea plants, the flowers were either purple or white. There were only two phenotypes, and each phenotype had its own genotype. But these are cases where the expected results, it's not what you would expect. So in chickens, yeah, that's in one case where we end up with an erminant, I probably butchered that word wrong. We'll just say a speckled chicken, right? White chicken crossed with a black chicken, and the chicken shows up speckled, and you can see that both alleles are present. They are shown on this mix of this chicken, right? And so the question is, this is an example of which inheritance pattern. Is it incomplete dominance or codominance? Well, when both alleles, okay, white and black, show up in the heterozygote individual, then this is codominance. Okay, so go ahead and write codominance here. I'm not going to, because writing it out on my mouse pad is just not ideal. Okay, so in some chickens, the heterozygous genotype leads to a phenotype known as erminant feathers, which are speckled with both black and white. There's that both show up, codominance. The allele for black is a capital B, and the allele for white is a capital W. For each phenotype below, identify the genotype. So black chickens, okay, in order for black chickens to appear, both of their alleles are capital Bs. White chickens, okay, white chickens, both of their alleles are the capital W. And then the erminant, that's heterozygous, so one of each. So capital B, capital W. So on our first Punnett square here, it says a black chicken. So what's the genotype for black? You should be thinking big B, big B. Okay, so I'm just going to write big B, big B. Is crossed with a white chicken. What's the genotype for white chickens? Oh, the only way you can be white is two big W's. Give the expected ratios for each genotype and phenotype. So I'm going to put one of the chickens here. I'll put the black chicken up here on my Punnett square. And then I'll put the W off to the side. Okay, and now we're going to go in and fill in our Punnett square. Big B from the top, W from the side. Big B from the top, W from the side. Big B from the top, W from the side. Big B from the top, W from the side. Okay, a bunch of Border West chickens here. No, I'm just kidding. Okay, so now we're supposed to give the genotypic ratios. So you look at your Punnett square and you write down all the different types of genotypes. And on our Punnett square, we only have one genotype. Okay, some cases you might have two, and some you might have three. So they want to know, hey, what's the genotypic ratio? So I only see one genotype in our Punnett square, big B, big W, and that is 4 out of 4. Okay, now they want to know your phenotypic. Well, I only got one genotype. If you're big B, big W, what type of chicken are you? You're this speckled erminant. God, I really should have just looked up how to say that word. I'm just going to abbreviate ERM, erm. All right, 4 out of 4. Okay, so there's a Punnett square at the bottom that you will do on your own. Okay, moving on to the second page. In snapdragons, flower color is by incomplete dominance. The allele for red is capital R, and the allele for white is capital W. So remember, in incomplete dominance, the heterozygous is a blend. Okay, so you can see in this picture here, a red flower crossed with a white flower ends up with pink. And so it says, knowing this trait is incompletely dominant, what would be the phenotype for the heterozygous condition? Please write pink. So this is the blended inheritance. All right, for each phenotype below, identify the genotype. Okay, so if you are red, using the letters R and W, well, red, that means you are two big R's. And if you are white, then you are two big W's. A pink flowered, pink. What's your genotype for pink? Up here, RW. It's crossed with the white flower. Big W, big W. So you're gonna start, go to your Punnett square. RW. That's my pink flower, crossed with the white flower. And then you're gonna go ahead and fill in the Punnett square and give me the genotypic and the phenotypic ratios. Okay, at the bottom of that, it deals with blood type. So remember, blood type is multiple alleles where there's more than one type of alleles. Usually when we've been dealing with two alleles, like big B, lowercase b, or maybe two different letters, big R, big W, right? Big B, big W. So blood type, there are 3 alleles, okay? There's, I don't know how you want to do this. Let's go A, and there's B, and then there's little I, okay? So homozygous, homo means the alleles are the same. For blood type A, big A, big A. Maybe we should fill in this table first. Okay, if you are little o, if you're blood type O, what are your genotypes? There's only one, and that's going to be little I, little I. If you are AB, then your genotype is AB. If you're blood type A, there's 2 ways. You could be homozygous dominant, so we can say big A, and the other way is big A, little I. B, there's 2 ways. You could be homozygous dominant, big B, or big B, little I. So then over here, they ask you for the names. They give you a type of blood. Like if you're type O, what's your genotype? So you just look at this table. Oh, type O, there's only one type. Little I, right? Hetero, geez, what does hetero mean? Oh, hetero means the alleles are different. And you have type B blood. Well, are these alleles different? No, they're the same. These alleles are different. So you'd write big B, little I. Okay. Oh, snap. Hold on here. I thought I had screenshotted the last page. Hold on. It won't take me long. I got it right here. Copy. Okay. Moving on to the final page. Okay. So the back page deals with blood types and some scenarios. Okay. It says a father who is heterozygous for type A blood. Okay. Heterozygous. Hetero means different. And if we looked at our previous table for heterozygous, big A, little I. So I'm just going to write big A, little I for his type A blood. And his mother is heterozygous for her type B blood. All right, hetero means different. Okay, so it's going to be big B, little I. What percentage of their offspring would you expect to have? And then I list all the blood types. So we're going to make a Punnett square. Big A, little I. Big B, little I. Fill in the Punnett square. Okay, so I got my Punnett square made, and now you just have to tell me the percent, not ratio, percent. So 1 square is 25%, so you just go ahead and fill in the appropriate percentages. The bottom one is another hospital switcheroo. Did the hospital make a mistake? So it says in 1968, a couple accused a hospital of switching their baby with another. DNA fingerprinting did not exist at the time, so the hospital traced the blood types of the family in order to determine if a mistake was made. The mother had type A blood. Okay, so think about the genotypes for type A. The father had type AB blood, and the baby had type O blood. Use the Punnett square to defend your answer to the following question. Did the hospital make a mistake and switch the baby? So this genotype is for sure AB, okay? This genotype could be big A, or it could also be big A, little I. And the only way you can have type O blood is little I. And you think about where an offspring gets their alleles from, okay? And then determine if the hospital made a mistake. So you might have to make 2 Punnett squares just to see if it's possible for the baby, for the offspring of these 2 parents to end up with type O blood. But you need to, for sure, make a Punnett square and then, a sentence saying, yes, the hospital made a mistake, or no, the hospital did not make a mistake, here's the proof. All right, so that's the assignment for today. Tomorrow, your review guide is due.